Okay, hi everybody. My name is Matt Hughes. My team is Fawad Khan, Yaro Sutlovic, and Anson Mercariker, and we're working on the SkymorphTO project, which is a project to interact with the Skymorph API in fun and educational ways. So what is Skymorph? Skymorph is an online tool that was developed by NASA to fetch imagery of asteroids, planetoids, and near-Earth objects, as well as present their motion across the sky so that people can detect asteroids that might hit us someday, or just learn more about the solar system. So the current form of the tool is not ideal. It currently exists as a rather cryptic online form that posts to a very slow Perl script, and you basically need to be an astronomer to know what you need to put into these fields. So it's very difficult to use and very difficult to understand. The worst part, though, is that it's very slow. Once you figure out what you need to put onto the form, it takes 10 to 30 to 50 seconds to grab even just one image, and then shows you nice little error messages as well. So part of the challenge was originally to develop a RESTful interface, which is basically generating a machine-readable output that programmers and scientists could then use as a base for developing better tools that use the Skymorph program. However, it seems like this was also a challenge last year and has already been implemented by a guy named Ian Webster from Mountain View, California. So we decided to simply extend what he created last year because it's really awesome. So thanks a lot, Ian Webster, if you are watching this. He's also currently using his project in space apps in the States as well. So it creates a machine-readable but still not human-friendly data set. That basically puts name parameters and is a bit more easy to use. But our challenge was to create a human-friendly, interactive, and accessible way of accessing this data. One tool we had available was Google Earth, so we decided to export this data as KML files that would basically put the images onto the sky in the correct position, the correct size, and correct orientation, and allow us to see the context of those images and load them much more quickly. We also wanted to implement leap motion control for very simple concept, at least, panning and zooming across the sky. This turned out to be very challenging. For one, how do you send this data to Google Earth? And also, it's a human-computer interaction problem, because how is someone supposed to move a map by waving their arms around? There's no real established way to do that. So we're going to show a quick demo. Escape. So what we have here is just a Google Sky thing. It's totally normal. But we also have a list of cataloged near-Earth objects. So I'm going to pick my favorite asteroid, Vesta, and bam, it's already grabbed the images, or a list of images anyway, and shows us in the context of the sky where it's been moving around over time. It also shows the images in their location in the sky, and you can see, since the asteroid's been moving around, its position in the sky changes over time. So we're going to use our remaining 30 seconds to try and plug in our Leap-enabled version of this app.
I hope this works. Okay.
Oh, you mean to mirror the displays.
All right. So this is our regular sky view. But now with the leap motion, we can do stuff like, oh no, it's not working. No. Here, let's try one more time.
Oh, there we go.
Yes, thank you very much.
You can come and play with it later if you want to try it out yourself.
Pretty cool. Can we get another round of applause for them?